Okay, so what I want to do in this video is I want to just kind of talk to you guys about what a programming language is and why you would use it to do statistics. Um, well, I guess to start out here, a programming language is simply a language that humans speak to computers, essentially. We're going to be using a language called R, which is a strange name, admittedly. But the name was actually derived from the first initials of its original two programmers, Robert Gentleman and Rossi Haka. And the decision to actually name the language just using a single English letter is what we might, I guess, charitably call a joke on the part of these two programmers. They kind of saw themselves as poking fun at R's parent language. That is to say, the language that R kind of evolved from. And that language had the unimaginative name S. So in the 1970s, the S programming language had kind of undergone its initial development at the famous Bell Laboratories, which you may or may not have heard of. And the primary aim of this language was to enable and to encourage good data analysis. And this was a goal that was so fundamental to the ethos of S that the authors of that language actually felt they had to they had to emphasize it using all uppercase lettering in the language's instruction manual, which I actually have a copy of right here. So if we just flip a few pages to the preface here, you can see the primary goal of the S environment is good data analysis, all uppercase. That's how you know they're serious about this. Um, so this kind of familial correspondence that the language R has with the language S is actually still present even to this day, to such an extent that you could actually probably use this manual as an instruction manual for R, because like the two languages are just that similar. But you might wonder, well, why would you use a programming language to do statistics? If you think about it, statistics is usually considered hard enough by many students and educators. Why would you want to kind of compound this with a programming language? I think it's a valid question. Why not, for instance, just use one of the many pieces of statistical software that already exist and don't, in theory, require any kind of programming knowledge? Why not use software like SPSS or Minitab, which you may have heard of or may have even used in the past? Um, well, the principal answer to this question really has to do with flexibility. The thing about good data analysis is it's not a rigid thing. It's not the case that there's always a single correct way to do things. Different data sets come with their own unique kind of intricacies and problems, which are often not amenable to the kind of cookie cutter, for lack of a better term, style of analysis that programs like SPSS employ. Now, that's not to say that those types of programs are not capable of adapting to these, various unique scenarios. They usually are, but this adaptation usually requires the user to pay for some additional feature that they didn't get in their original purchase, or it demands a much higher level of expertise with the software than most users are ever likely to actually acquire. It basically amounts to the user having to learn some obscure programming language kind of specific to that program or that software. Along these lines, something that non-R users often don't appreciate is how easy R is to learn. So at a superficial glance, something like R, it can appear intimidating, but it's actually fairly intuitive and it works more or less in the manner of a calculator. Now, obviously, this is purely anecdotal on my part, but what I've found is most people who learn R tend to find it to be a fairly rewarding experience that was considerably more user friendly than what its paid counterparts like SPSS and Minitab produced. And this is really thanks in large part to the extensive infrastructure of online resources that our users have built over the years, which proprietary software like SPSS and like Minitab just have no equal to. the community that has been built around the R language has done some pretty remarkable things. Software like SPSS and Minitab, these these types of software, they can initially give a user this kind of air of familiarity and comfort when they first encounter them. Because if you look at these types of software, they appear very similar to kind of commonly used spreadsheet software that a lot of people will already be kind of familiar with. So stuff like Microsoft Excel. So actually, I have a screenshot here of a window from SPSS. And you can see at first glance, the whole thing looks pretty innocuous. It looks fairly friendly. There's nothing too scary or intimidating about this. Basically, the user is given kind of a bunch of buttons and menus near the top, and you have this kind of spreadsheet, this sort of spreadsheet style grid beneath it. But the sad truth here is that that is really where the similarities between it and something like Microsoft Excel end. Users new to something like SPSS are inevitably going to find themselves overwhelmed, I think, by the plethora of bewildering options that it has. And even tasks which should be fairly simple, like loading and viewing a data set, is actually a fairly unintuitive process. The dirty little secret about programs like this is their learning curve is a lot steeper than the advertising would have you believe. By contrast, there's an inherent logic to R. Um, and that's the logic of mathematics. And even people who aren't terribly good with math can usually easily grasp and build off of that logic pretty easily. The other great thing about R, in case you didn't know, is its cost. R is free for the user. There's no need to put up with annoying advertising or paying for additional features. The same cannot be said for software like this, like SPSS or Minitab, which are almost always subscription based, requiring the user to renew an expensive license, just to use the software. In fact, if you want to have a fun little game of sort of hide and seek, um, what I'd recommend is go and visit the website for something like SPSS or Minitab and see if you can find a price listing on their website for their software. Now, you'd assume that wouldn't be a very difficult task, but you'd actually be wrong. It's basically an impossible task. Kind of evoking that age old wisdom that, if you have to ask, you probably can't afford it. But R is not just free in monetary terms. R is also free in philosophical terms. So R actually adopts the Free Software Foundation's GNU general public license, and thus it adheres to the philosophy of free software, which is what a lot of people just commonly refer to as open source. So if you actually head to the GNU project website, which I have open here, you can see the 4 essential freedoms of free software right there. So, you have the freedom to run the program as you wish for any purpose. You have the freedom to study how the program works and change it so that it does computing as you wish. And access to the source code is a precondition for this. You have the freedom to redistribute copies so you can help others. And you have the freedom to distribute copies of your modified versions to others. By doing this, you can give the whole community a chance to benefit from your changes, and of course, access to the source code is a precondition for this. And these freedoms, they extend as much to the software's various file types and help documentation as it does to the software itself. And the thing to appreciate, really, and why this is so important, is that for many years, the kinds of paid software that has typically been used in research has almost exclusively relied on proprietary file formats to handle data. So, for instance, many types of paid software that's used for building, running, and analyzing experiments in science will, by default, output their results using restrictive file formats that actually require the original software with a valid paid license to be read. Now, that not only makes it difficult to provide free access of the data to other researchers, but it makes it that much more difficult to load the data into other types of software for more in-depth analyses. Now, obviously, in a bygone kind of pre-internet era when statistical computing was a lot more complex and expensive to conduct, and we're also talking about a time when the use of any given computer was restricted to just this kind of small coterie of researchers. You could, under those conditions, maybe forgive a company for utilizing kind of proprietary formatting schemes in this manner. However, we now live in an age where the internet is ubiquitous, and there's not really any good reason to ration computing power anymore. So there's not a good justification for practices like these. In most cases, a generic CSV spreadsheet file, which is just a universal standard for spreadsheets, is sufficient as an output for most research endeavors. And we'll discuss CSV files and stuff in more detail at a later point. In any case, it's clear to any reasonable person that this kind of behavior of locking things behind licenses and restrictive file formats is not done in the best interest of scientific progress. Rather, it's done simply to tether researchers to a branded ecosystem of overpriced software. Consequently, we can fairly easily label the continued adoption of these practices for what they are. They're unscrupulous. So the moral of the story here is really you should use R to give the middle finger to these companies.